Everyone, today I will explain you functional group identification test for neutral compounds. Neutral compounds are those in which carbon, hydrogen and oxygen is present, and these compounds are exceptional to soluble in water, that is they are insoluble in water and soluble in concentrated H2SO4. Today, I will explain you functional group identification test for aldehyde, ketone, quinone, ester and anhydride. Let's see first aldehyde and ketone. Aldehyde and ketone have the common functional group as carbonyl group, as we know. So what we do for identification of carbonyl group, that is 2,4-dinitrophenyl hydrogen test. So how the test will perform? Like this, aldehyde ketone reacted with 2,4-DNP to form crystalline precipitate of 2,4-dinitrophenyl hydrazone. So how the proportion is, add 2 drops of or 0.05 to 0.1 gram of the substance to be tested to 3 ml of 2,4-dinitrophenyl hydrazine with wait for 10 minutes. If no precipitate form, then after 10 minutes you will find that crystalline precipitate forms. It indicates the presence of carbonyl group in our compound. So we can conclude that either it is aldehyde, ketone or quinone. So occasionally the precipitate oily at first, but it did become crystalline upon standing. After that we find that our compound have carbonyl group. We will further test of Schiff's reagent, that is Schiff's test. First of all, you should know what is the Schiff's reagent. Schiff's reagent is a colorless solution obtained by passing sulfur to sulfur dioxide gas through magenta colored solution of para-rosanilin hydrochloride. So like this you get the Schiff's reagent. How we use? Aldehyde produces pink color after reaction with Schiff's reagent, while ketone are without effect. So what we do, use 2 drops or 0.05 gram of the compound and 2 ml of Schiff's reagent and shake the mixture in cold. Some aromatic aldehyde, for example phenylene, give negative taste. So this is the reaction, which is Schiff reagent colorless with reacting with the our given sample to, this is the aldehyde, and to form the pink color 2,4-DNP, 2,4-dinitrophenyl hydrazone. This is how result look like: colorless, negative, aldehyde is absent, and here aldehyde is present. Then the second test is a tolerance test. What the tolerance test, we need to remember that in tolerance test there is a presence of, or we find silver mirror inside the test tube. So how the reaction is carried out? Like this, 2-3 drops of the aldehyde add with the 2-3 ml of tolerance reagent to form the silver mirror in the test tube. And we need to take caution that after the test, pour the content of the test tube into the sink and wash the test tube with dilute nitric acid. Any silver fulminate present which is highly explosive, when dry, will these be destroyed. Then this is the examples. First is cyclohexanone and second is benzaldehyde. Then third test is the iodoform test for methyl ketone. Iodoform test is basically indicate that presence of ketone in our compound. So what we do, if that substance to be tested is water soluble, then dissolve 4 drops, and if it is a solid, then add 50 milligram in 2 ml of water in large test tube. Then add 2 ml of 3 molar sodium hydroxide and add slowly iodine in the test tube. You will find that if there is a positive, how we can show it show presence of brown color of the reagent disappearing and yellow iodoform solid precipitating out of the full solution. Like this you can see this picture, and the example is acetone. Then the next test in the neutral compound is test for quinones, which is hydroiodic acid. Compounds of para-benzoquinone type liberate In the test for quinones, let's see the reaction. Add 1 ml of potassium iodide to 1 2 and add 1 2 drops of dilute H2SO4 in this. So it forms potassium sulfate, that is K2SO4, and hydrogen iodide. This hydrogen iodide further add to 0.2 gram of sample. So you will find the pale yellow color is developed in solution, and appearance of blue color on starch paper that proves the presence of quinone. For example, benzoquinone. Next test for quinone is the reduction of oxanthol. In 0.2 gram of unidentified compound, that is our sample, add 5 ml of 10% NaOH solution and heat the given solution after adding small amount of zinc dust. So we find intense red color which produce vanishes on shaking. This confirm the presence of quinone. Then next identification test we will perform for ester and acid anhydride. When compound failed to respond to 2,4-dinitrophenylhydrazone test for aldehyde and ketone yet exhibit carbonyl absorption in the infrared region, it may either ester, acid anhydride and possibly lactone. So leave lactone, we will test for ester and acid anhydride. So what is the differentiation between ester and anhydride? We need to know that how we can differentiate between ester and anhydride. The basic difference is that hydrolysis of acid anhydride is more rapid than that of ester in basic condition. So let's move for the ester identification test. First is phenolphthalein test, hydrolysis. What we should do, take a 0.2 ml of unidentified compound, that is sample, add 3 ml of dilute NaOH solution, 1 ml of phenolphthalein solution. We get the pink color is obtained due to presence of NaOH solution. This is the presence of NaOH solution. It form pink color, and we will heat the mixture and observe the we should to heat the mixture and observe the color change. If it is the colorless, if the color changes to colorless, then possibly it form the it give positive result for ester. So it is possible that our sample have presence of ester. So this is the hydroxamine acid test. What we should to do, take 0.2 gram of um, ml 0.2 gram if it is solid, and 1 to 2 drops of given sample, or 1 to 2 drops. Then add 10% of NaOH solution till alkaline and heat to boil. Cool the solution and neutralize by dilute HCl, and add 1 2 drops of aqueous FeCl3 solution. So appearance of red violet color confirm the presence of ester. This is the 0.2 this is the 0.2 gram of sample. Then to 10% NaOH solution and neutralize, and we will add 1 2 drops of aqueous FeCl3 in this intermediate. This is we perform neutralization by aqueous HCl, by dilute HCl, and here with 10% NaOH solution to form this intermediate, and we reacted to FeCl3 to form reddish violet color compound. It indicates the presence of ester. So now the identification test for anhydride. The first test is hydroxamic acid test. What we do for it, add 0.2 gram of or 0.2 ml unidentified compound, that is our sample, and add 0.2 gram hydroxylamine hydrochloride with 5 ml of 10% NaOH solution. Boil it for 1 minute, cool it and acidify with dilute HCl, cool again, and few drops of aqueous FeCl3 solution and shake and observe. A deep brown red coloration implies the presence of anhydride. This is how the test perform. This is the 0.2 gram of sample, then 5 ml of 10% NaOH, boil it for 1 minute, cool and acidify with dilute HCl and cool again. And we should to add few drops of aqueous FeCl3 to form ferric hydroxamide complex. You will find deep brown red color, so it indicates the presence of anhydride in our sample. Next test is fluorescence test for anhydride of some dicarboxylic acid. So take 0.2 gram of or 0.2 ml of compound, add 0.2 gram resorcinol and 0.5 ml of concentrated H2SO4. This is the concentrated H2SO4 and we should to heat it. It form fluorescein. Heat it for 1-2 minute. To this mixture we should to heat this mixture for 1.5 minute. Pour the mixture into beaker containing 5 ml of dilute NaOH solution. Appearance of green fluorescent. This form appearance of green fluorescent color solution confirm the presence of anhydride. It not only give just inference that it present, but also it confirm the presence of anhydride. So for anhydride we should do two tests. Basically first is hydroxamic acid test for indicates the presence, and for confirming that we have anhydride the fluorescent test is there. Likewise we perform two tests for ester. First is phenolphthalein test, where we find that maybe ester is present in our compound, and in the next test we will confirm that uh, ester is confirmed in our sample. So I take a reference from Vogel's textbook of Practical Organic Chemistry, 5th edition by B.S. Furnace and P.W.G. Smith, page number 1218 to 1223, POC textbook of Nirali publication by Dr. K.S. Jain. Thank you.